Dear students, welcome to Blackboard. Areas of parallelograms and triangles. Two figures are called congruent if they have same shape and same size. We have studied it. If two figures are congruent, they must have equal areas. But two figures having equal areas need not be congruent. For example, you see here I have drawn a rectangle and a square. Rectangle is having length 9 cm, breadth 4 cm. Square is having side 6 cm. Both have area here 9 into 4 36 cm square and here 6 into 6 36 cm square. Same area. But we can see their shape is different. They have different shape and different size. So they are not congruent. So the shapes which have equal areas need not be congruent. But two figures are congruent. They must have equal areas. So we can say area of a figure is a number associated with the part of the plane enclosed by the figure with the following properties. If A and B are two congruent figures, then area of A equal to area of B. Another property is if a planar region formed by a figure T is made up of two non-overlapping planar regions formed by figures B and Q, then area of T equal to area of P plus area of Q. That means here I have drawn a figure. This is a planar region. This we can name as T, and you can see T is a combination of the region P and region Q. They are not overlapping. That means the one region is not on the other. They are separated. So to find the area of this T, we need to find out the area of P and area of Q. Then have to add it. That is area of T equal to area of P plus area of Q. Figures on the same base and between the same parallels. Which of the following figures lie on the same base and between the same parallels? In such a case, write the common base and the two parallels. You see the first figure. Here you can see this trapezium ABCD and this triangle DPC. Both are lying on the same base DC and between the parallels AB and CD. Here you can see both the figures are lying on the same base SR, but they are not lying between the same parallels. Here this trapezium MNSR is stopping here. The next figure, you can see this triangle TQR and the parallelogram PQRS. Both are lying on the same base QR and lying between the same parallels PS and QR. Here, both are lying between the same parallels, but you can see the base is different. Here the base is PQ only, but the base of the parallelogram is BC. Here you can see both are lying on the same base AD and lying between the same parallels AD and BQ. Here it is not on the same base and between the same parallel lines. Parallelograms on the same base and between the same parallels. Theorem 9.1. Parallelograms on the same base and between the same parallels are equal in area. Here you see the figure. You can see parallelogram ABCD and parallelogram EFCD. Both are lying on the same base CD and both are lying between the same parallel lines AF and DC. So by theorem we can conclude that area of parallelogram ABCD equal to area of parallelogram EFCD. Next, triangles on the same base and between the same parallels. Theorem: two triangles on the same base and between the same parallels are equal in area. Next theorem: two triangles having the same base and equal areas lie between the same parallels. See the figure. You can see this triangle ABC and this triangle BDC. Both are lying on the same base BC and lying between the same parallels AD and BC. So, according to the first theorem, if two triangles lying on the same base and between the same parallels, then their areas are equal. That is, area of triangle ABC equal to area of triangle BDC. Second theorem states that if two triangles are on the same base and their areas are equal, then they are lying between the same parallel lines. In figure, ABCD is a parallelogram and EFCD is a rectangle. Also, AL perpendicular to DC. Prove that. First question, area of ABCD equal to area of EFCD. Second question, area of ABCD equal to DC into AL. Now you see the figure. Here you can see this ABCD, which is a parallelogram, and this EFCD, which is a rectangle. Both are on the same base DC and between the same parallels EB and DC. Therefore, we can say by the theorem, area of parallelogram ABCD equal to area of parallelogram EFCD, because rectangle is also a parallelogram. So we have proved area of ABCD equal to area of EFCD. Now we have to prove the second one, area of ABCD equal to DC into AL. You see, here it is given AL is perpendicular to DC. And we know this FC is also perpendicular to DC. So we can say this AFCL is a rectangle. So this opposite sides, that is AL and FC, they are equal. Area of ABCD is equal to area of EFCD. So EFCD is a rectangle, its area length into breadth. Here length is DC and breadth is FC. So we can write DC into FC. Here we have proved AL equal to FC. So this FC we can replace by AL. So we get area of ABCD equal to DC into AL. If a triangle and a parallelogram are on the same base and between the same parallels, then prove that area of the triangle is equal to half the area of the parallelogram. So here is drawn the figure. Here this triangle PAB and parallelogram ABCD are on the same base AB and between the same parallel lines AB and PC. We need to prove area of this triangle PAB is equal to half the area of the parallelogram ABCD. Here we are going to do a construction. Draw BQ parallel to AP to obtain another parallelogram ABQP. You can see one more parallelogram here formed. It is ABQP. Now you see the figure. You can understand this parallelogram ABQP and the other parallelogram ABCD. Both are lying on the same base AB and between the same parallel lines AB and BC. So we can say area of parallelogram ABCD is equal to area of parallelogram ABQP. Let it as equation number 1. Now you see this parallelogram ABQP. You can see this PB is the diagonal of this parallelogram. And we have studied diagonal of a parallelogram divides it into two congruent triangles. So this triangle PAB and this triangle BQP are two congruent triangles. And we know if two figures are congruent, their areas are equal. So we can say area of triangle PAB is equal to area of triangle BQP. Now you can see this area of this triangle PAB is half of this parallelogram ABQP because this diagonal divides it into two equal triangles. So we can say area of triangle PAB is equal to half into area of parallelogram ABQP. But we know area of parallelogram ABQP is equal to area of parallelogram ABCD. So we can replace it. Therefore we get area of triangle PAB equal to half into area of parallelogram ABCD. So the result, if a triangle and a parallelogram are on the same base and between the same parallels, then area of the triangle is equal to half the area of the parallelogram. Show that a median of a triangle divides it into two triangles of equal areas. Here is drawn a triangle ABC and AD is its median. We need to prove this median AD divides the triangle ABC into two triangles of equal areas. That is, we need to prove this area of triangle ABD is equal to area of triangle ADC. To prove this result, we need to do a construction. Draw AN perpendicular to BC. Now let us find out what is area of triangle ABD. Area of triangle ABD equal to half into base into height. The base of triangle ABD is BD. So we can write a half into BD into AN. And we know this AD is the median. So this BD and the CD both are equal. So this BD we can replace by CD. Then we get that is equal to half into CD into AN. Half into CD into AN is the area of triangle ACD. So we get that is equal to area of triangle ACD. Therefore, we can conclude area of triangle ABD equal to area of triangle ACD. Dear students, I hope you understood the topic in this video. If you have any doubt, please comment.